The Demonstrator project enables us to improve our monitoring capabilities for biodiversity. And this is very important because there's a dramatic biodiversity decline in our planet, and agriculture has a very large role to play there and will need to improve in terms of its farming practices. And what we're trying to do here is both improving our monitoring of biodiversity and also at the same time testing different ways of helping biodiversity to thrive in farming systems. So one of the most important aspects of the PhenoRob vision is to reduce negative impacts of farming practices on ecosystem functions. And one of the most important functions in agricultural systems is pollination. And here we help pollinators through provision of pollen and nectar to thrive in our systems, providing flowers and then also helping to measure the impact of our new innovative designs on the pollinators itself, so that we can see whether we are successful with our measures.
In this research, we want to enhance and quantify the abundance of beneficial insects. For that, we conduct a field experiment, as you can see here. We grow maize and these flower mix and phacelia solae, but we also combine them. We combine maize with this flower mix, as you can see here, and maize with phacelia. And the aim is to enhance the biodiversity and the habitats and fodder for insects in maize. Additionally, we test different technologies to quantify insects. For that, we installed cameras and microphones in the field. And these audio data and images and videos are then later used and analyzed with a deep learning tool. Additionally, we conduct classical measurements. We catch the insects with a net and we install traps. In this demonstrator, the disciplines ecology, crop science and computer science are combined. Together we want to, first of all, develop a new cropping system based on maize with enhanced biodiversity. And we also try, test and develop a new technology that aims to quantify, detect and trace insects in the field using deep learning technologies.
The technology at the core of the demonstrator is a machine learning model, in particular a neural network, which is able to detect bees in images. To develop such a model, we take images from our experimental fields and then we mark these bees with bounding boxes in these images. And with this data, we are able to teach the model what bees look like, so that the model is later able to identify them in unseen new images. And this is challenging because the bees are very, very small, and even for us, it's very difficult to find them in these complex images. And our task in the demonstrator is to develop such a model that can tackle with these challenges.